Hello, today we will discuss about approximation in numerical computation. So, numerical computation is an approach for solving complex mathematical problems using simple arithmetic operations. So, as you are performing arithmetic operation, so the number of operation gives the error in steps, each and every step. So there are three ways by which the error will be involved. Number one is the initial. When you are performing any experiment from where you are gathering the data, so you may have some error in the system. So this is known as the initial. And the number two is the round off error. So round off in the system, you are doing some numerical computation in some of the arithmetic operation you are performing. So each and every time you are rounding off, you are chopping off that particular digit. So there will be certain percentage of error in the system. And the last one is known as the truncation. So when you are performing any experiment, when you are rounding off, when you are using this thing, you are basically using some formula. So this formula may be truncated when you have the infinite nature of this particular formula. Now, in details we will talk about the rounding of error with some examples. So in computation, a rounding of error or round off error is the difference between the result produced by a given algorithm using exact arithmetic and the result produced by the same algorithm using finite precision rounded arithmetic. So now take an example that rounding multiple times can cause error accumulation. So you are performing the things number of times, so error will be there for each and every step. So example we are taking, see you have a number something like this, 9.94530. So if you want to rounding, so every time taking this large data, it's not that easy. So we need to rounding off, we need to chop it up. So how much we will to chop it up? Up to 2 decimal places. So up to 2 decimal places means up to this position. Now see, now 9.94, then after that you have 5. So as it is 5, so we are going to add 1 over there. So this becomes 9.95. Okay. So now see, if you want to rounding off again, now this number 9.95, this is very close to 10. So you can have a approximation. So now if simple number 9.945309, it's approximated to 10. As it is approximated to 10 or as it is rounded off to 10, so there will be error of 0.054691. Okay, so as your round. Same way you can take another example, 4.845. So in simple way, so it's an approximation of 4.9, or you can approximate it 5. So 5, actually the number is 4.845. Okay. So if you are approximating, you can make it 4.9. As this is 4.9, is very close to 5. So in some of the experimental setup, somebody may work with this, somebody may work with this, somebody may work with this. So in last two cases, obviously there will be some approximation, and here this approximation is due to rounding off. So there will be error in final calculation because there will be number of steps where you are calculating. So each and every steps you are rounding. So error will be. Then the truncation error. So truncation error is a simple example. If you are taking a exponential series, e to the power x is 1 plus x square by 2 factorial. Then x3, x4, this will be for a infinite series. but this is quite not possible to use infinite series number of time. So, or large number of cannot be used. So, you need to approximate. So, up to which you will going to approximate, this will depend on the user. This will depend on the particular problem. But here, we are just truncating this higher order term. Up to this portion, up to this term, we are considering the higher order term is negative. So, if you are doing this thing, so you are really adding a truncation error in the system. You are truncating up to this part, so you are adding some error. A simple way to explain this thing, to take an example of a function 5x cubed. We need to find the derivative at point x equal to 7. Okay. So, if you are doing this thing, so analytically one can say if you have this function, so the derivative will be 5 into 3x square. 5 into 3x square means 15x square. Now, x value is given as 7. So, it becomes 735. So, analytically, if you are calculating this thing, you will get. But if you are using this thing numerically, so differentiation can be given as f dash x. It can be given as f of x plus h minus of fx divided by h. So, where actually here that you have a limit term, limit h tends to 0. If h is very, very small, then you can. So, we are considering 2 points over there. So, the one point is 7 and the next point is 0.25. So, we are considering 7 plus 0.25 and the earlier one is divided by 8. So, you got it. Now, see, so there is some approximation by using this numerical. So, we are truncating. So, there will be certain error. So, basically, you can find the difference between these two and this will obviously give you a sufficiently large error. Now, as you have some numerical number with some decimal number, okay, so there will be two possible representation of this number. One is the fixed and another is the floating point arithmetic or the number one. So, what is fixed point? So, the fixed point number just means that there will be fixed number of the digits after the decimal point. So, you have certain numbers, say 1, 2, 4 and then after that you have decimal, there will be some digits after this one. So, you are going to fix this one. If you are going to fix this thing, say there will be after decimal point, you are going to consider only 2, only 3 or only 1. So, this will be fixed number point, fixed point representation or fixed point arithmetic. And if you are not fixing this thing, so you are considering large number of varying number of digits for different operations or different calculation, you are taking different number of digits. So, then this will become floating point. Okay. So, in one case you have fixed the number of digits after decimal, in one case you are not fixed. So, example, so here we have taken after decimal there will be 2 points, after decimal there will be 2 points, 2, 3, 4, 1, 2, 3.45, 2 decimal, after it's 2.56, only 2 values. Okay. So, now this will be fixed point, but there will be floating point. Now, see, floating point it's not fixed. So, this may be after decimal there will be 5, 6 numbers, there may be 1 number, there may be 7, 8 number of decimal points. Okay. So, digits are variable digits. Now, the next one is the propagation of error. So, from where it propagates. So, as it was mentioned that there are two ways to get the error or two way to propagate the error. Number one is from the experiment directly. So, what is your experiment? Whether this will be inside the lab or outside the lab, you are performing some experiment and you are gathering data from this. If there is some error, when you are performing the experiment, if there is some error, so this will be there in the system. So, the intrinsic error, you really cannot remove this. Or the main aim is to minimize the error. And the second way is when you are calculating. So, when you are calculating this thing, so there may be you are using some formula or after calculation you have some numerical value. So with number of points after decimal, before decimal. So if you are approximating, if you are truncating, or if you are rounding off, there will be error. So there are two ways to get this. Number one is the individual measurements, experiment you are performing, and another one is the mathematical operation what you are. So the propagation of error, so we are going to represent this thing by a simple example. So here we are considering somebody is moving from one point to another point. It starts from CTA to B. So the CTA to B, the distance is given as 52 plus minus 0.02 miles. Okay. And then from B to C, somebody travels with a distance of 78 plus minus 0.02. Now, so total distance covered. So this is one of the set of experiment, one set of experiment, and here this is the another set of experiments. So two experiments are there. So now here the distance cover is A to C. So the total error will be propagated from 1 to. So if you are traveling from C to D, D to E, so every time there will be some error, and this will be propagated each and every time, and this will be added every time. So as you are doing numerical methods, you need to minimize this one. So to get a approximately better result. Thank you.